Assalamualaikum everyone. Today we're going to cover topic LIGA. Here are some LIGA technology that we are going to cover today. There are some history of the LIGA, synchrotron X-ray LIGA process, issue with LIGA, and LIGA-like process. First of all, what is LIGA? LIGA is the combination of three processes that taken from Germany, which is lithography or lithography, electroforming or galvanoforming, and molding, which is abforming. So that's Li taken from lithography, G from galvanoforming, and A from the abforming. So this words is coming from Germany. Okay, this process is invented by the Wolfgang Achbert in 1982. So this is a company where it's called KFK, based in the Germany. So LIGA is first used in USA in 1988. LIGA first was initiated by KFK, intended to mass produce of the micro nozzle for uranium-235 enrichment. So in KFK, they use 2.5 GeV storage ring in order to exposure the PMMA resist. Nowadays, LIGA and LIGA-like process are performed in many laboratories, and many research has been done around the world. So the goal for this industry is to develop the ideal mean of fabricating micromold for the mass production of precise micro machine. Okay, so that's the target in the industry. Okay, so here are some important features of the microstructure produced by the LIGA. So the first one, it can produce up to 1 mm surface dimension, 20 to 100 aspect ratio in depth, and then 30 to 50 nanometer surface roughness, and 0.5 to 1.0 micrometer per mm vertical pattern fidelity. Okay. In LIGA, synchrotron X-ray is used to perform the operation. So synchrotron radiation is emitted by electron orbiting in the storage ring. If you can remember, in the X-ray lithography previously, we already see the synchrotron X-ray, how the electron orbiting the storage ring is produced. Alright, so it provides ultraviolet and X-ray radiation, so that this will use for a wide range of analytical techniques. So acceleration of high energy electron travel at high speed generate radiation. So this one is repetition from the previous one. So the methods of the synchrotron X-ray is the same like what we see in the lithography previously. So and the previous one, we see that the electron is being circulated right into a high energy electron, okay, in circular motion, so that you will be able to get the X-ray synchrotron X-ray, right? So this one is the example of the low density synchrotron X-ray, but in the LIGA there will be high density synchrotron X-ray, like the one that used in this one. Okay, so there will be many section containing periodic magnetic structure. So if you can see this one, if let's say is this just only one way where the electron can come out, okay, so this one only one channel, okay, so but this one there will be the shape will be like this, so that there will be more area where the photon can accelerate out. Okay, so here is the example on the synchrotron X-ray in the LIGA, which is we call as spring 8, where the electron energy will go at up to 8 GeV. Okay, so in this process, the wide synchrotron radiation can be obtained over a broad range of wavelength. So there will be far infrared, vacuum, ultraviolet, X-ray, and even gamma ray. Okay, so in this process there will be bending magnet that can bend the electrons. Okay, so that they can channel the electrons. In the production of the synchrotron X-ray, there is undulators in the LIGA process. Okay, so the undulators are periodic magnet structure which produce synchrotron radiation. So its habit exhibit a spectral brilliance up to 10,000 times higher than the conventional bending magnet. So if previously I showed the bending magnet, so they use the undulator to amplify the production of the synchrotron radiation, so by 10,000 times higher. So the overlapping wave of synchrotron radiation interfere with each other. By this interference, monochromatic synchrotron radiation of higher brilliance at a specific wavelength can be created. Then how does the undulator look like? So if you see the previous one, the magnet is only one is north and one on the bottom is south, right? So but this one, they created the north south and put all the magnet together like this in arrangement, so that the electron will move in zigzag area. Okay, so that they will be accelerating higher compared to the only one bending magnet. Okay, this synchrotron X-ray can be used in many application. Okay, for example, the structural analysis in terms of atom, molecules, protein, cell, crystal, and then chemical analysis, surface or bark. Okay, and then they can be used also in microscopy for photoelectrons and X-ray, and most importantly in the micro and nano fabrication, like the one that we see in LIGA. So you can use in X-ray lithography, thin film, etching, and other than that, they can also be used in medical diagnosis for radiology, angiography, and tomography. So this one is used for the use of the synchrotron X-ray. As I mentioned in the definition previously on the LIGA, okay, so now we go to the three stages of the LIGA. As we know that there are three processes involved in the LIGA. One is the lithography. So in this area, we call it as synchrotron X-ray lithography. And then it is involved electroplating and molding. Okay, so the first process involved with the synchrotron X-ray lithography, this is like the normal process of lithography, that you have to have the substrate, right? And then you put the mask, and then you put the resist, and then you perform the synchrotron irradiation on the material. Okay, so by doing this, you will get the second part, where you are going to have the resist structure after the synchrotron radiation, when we already do the etching and remove everything. Okay, so then you will get this resist structure. So after that, there will be electroplating with the metal. So then when you already perform the electroplating with the metal like this one, you're going to have the resist structure inside here and the metal on the outside. All right, so now when we remove the resist inside the metal here, okay, when there is a etching of the resist, you will be left with the mold here. So you already have the mold. So then what you have to do is perform the plastic molding compound. Okay, it's meaning that this will react as the mold for the mold cavity, and then you can place the plastic structure inside there, and then remove the metal structure here, the plating, and then you will get the final product. Okay, so that's the three process of the LIGA. So you start with the synchrotron X-ray lithography process, like the usual one that we look previously, that we already learned, only that they use the synchrotron irradiation. and then you create the mold by using the electroplating, and then by using the mold you perform the molding process, and then you'll get the final product. So that's the 3 stages of LIGA. So here is another example on the desired product that we want to be produced using the LIGA. For example, this one, a tube that we want to produce. Okay, so then there will be a substrate which you put the resist, and then you put the mask. Okay, this is the gold plated region mask. Okay, so then lithography is performed on this area, so you will get the mold like this one. Okay, so then by using this one, electroplating is performed on the process, and then after you remove the electroplating, then you will get this metal tube. Okay. Some example of the microcomponent fabricated by LIGA include the micro-sized gear, chemical reactor, turbine or channel. Okay, so for example, in the picture here is the ceramic micro turbine located under the FISM. Okay, so then you will see this one is 100 micrometer in size. Okay, so this is the product. Here are some collection of the product produced via the LIGA process. However, there are some issues related to the LIGA technology. For example, they have very high capital investment for the machines that we want to produce for the first place, and then to operate the machine also require high operating costs. Okay, so apart from that, the process will be very complex. Okay, and it require high level of technical skill to maintain the synchrotron facility, and it also difficult to maintain vertical sidewall. Okay, so for example, this one, it is difficult to get the vertical sidewall like this. Okay, and there might be some problem also with electroplating. If there are voids, so then it will cause defect, so then that will be the downfall, because it involves a high cost for the operation, right? And then it also difficult to achieve higher adhesion between PMMA and base as required by LIGA process. So sometimes there will be some problem also with the resist, which is the PMMA, which is the material that usually used in the as the resist in the LIGA process. So in LIGA, usually the mold insert are produced by the synchrotron X-ray, like I've mentioned previously. Like, so through this synchrotron X-ray lithography, it can produce a very high quality microstructure. So that's why they use the synchrotron X-ray lithography, so that you will get a very good quality, right? But almost all the complexity and expenses come from this step. Okay, so this step is the most consume the money the most. Okay, so cost reduction is one of the main goal of many researchers worldwide. So that's why um, depending on the size, accuracy, cost, and most insert, they can replace this process, this LIGA process, the first one, by using the synchrotron X-ray lithography, with other process to create the mold. Okay, they can replace it with FIB. They can also replace with laser. It can replace with micro EDM, CNC, or many other process, so that the cavity can be created, so that it can produce the mold. So it can also use the UV or dry with SU8 resist and silicon micro machining. Some cost analysis if the LIGA is replaced with the FIB. Okay, so for example, the micro feature that need to be created is around the diameter is 50 micrometer, depth 200 micrometer, 50 to 60 nanometer RA. Okay, surface roughness. Okay, so now the material is nickel, for example. Okay, by using the same method, LIGA total fabrication cost can go up to 5,200 US dollar. But for FIB, you can reduce the cost to the 2,300 US dollar. So meaning that more than half of the um, cost, right? So then the cost, in terms of the cost of effectiveness, it can go 2 to 3 times, okay, depending on the complexity of the product that we want to produce. Okay, so this one is just example on how the if you want to compare between the FIB and LIGA. That's why the process usually replace with the LIGA like process. You can look into these videos also for a better understanding on the LIGA process, and you can see some example on how the product is produced via the LIGA. So that's the end of LIGA topic. So we're going to continue with the microfabrication as our last topic for this semester.